Today we're going to be looking at not just solving two-step equations, but looking at examples from the real world and how to write a two-step equation and then practice solving. So here is an example. Bill designed a workbook for 7th graders to use during the summer to improve their math skills. He has a budget of $500, so that's how much, the most he can spend, to have the workbook printed. He received a quote from Speedy Print of $3 per workbook plus a flat rate of $80 for setup. At this rate, how many books can be printed? Now, as you saw that as I was reading through this, I was circling information that I thought was going to be important. And these are the things you're going to look for to help you write the equation. We know that he has a budget of $500. So that's how much he can spend. So that's our equals. He is spending $3 per workbook. When you see this word per right here, this lets you know that you're going to be doing it for every workbook. It's $3. So that's going to be a multiplication. So if we set that up like 3x, if there was one workbook, it would be $3. If there were two workbooks, that would be $6. So that tells us that we're going to be multiplying at times an unknown number because we don't know the number of workbooks. So that is going to be our 3x. Plus a flat rate. Well, plus means you're going to be adding a one-time fee of $80. So we're going to be adding $80 to this. So when I wrote the equation, I wrote it $80 for the flat setup fee, plus he's going to be spending $3 per workbook. That's our unknown number that we're looking for. And the total cost was $500. So you have to look for keywords like per, which tells you to multiply, plus, which tells you to add. You're always going to be creating today two-step equations. And in these two-step equations, you're going to have a variable being multiplied by something, and then you're going to have a number that's either added or subtracted. So you're going to see a pattern like that as we practice this. Now we're going to solve this as we did yesterday with any two-step equation. Remember that we want to figure out how many workbooks. That's what the x stands for. So we want to get the x, the number by itself. To do that, we have to move the 80 and the 3 to the other side. We always move what's being added or subtracted to the other side first, if you remember yesterday's lesson. So we're going to subtract 80 from both sides first. That gives us 3x still left on the left side, and 500 minus 80 is 420. At this point, our variable is being multiplied by 3, and the opposite of multiplying is dividing, so we're now going to divide by 3. So if we divide both sides by 3, we find that 420 divided by 3 means that he can have 140 workbooks. Now to check this, we could go back to our original equation up here. Now we know the number of workbooks is 140. Can't see that one right there. We're going to plug it back into the equation and see if we get it. So if we plug it back in, it would be 80, that was the flat fee, times $3 per 140 workbooks. We do our multiplication first, and then we add our 80. That would be 80 plus 420, and it does check to be $500. So you're going to be looking for keywords that let you know how to set up a two-step equation. Here's another example. Erin is interested in a career in forest management. She is planning to take classes at a college where the tuition is $135 per hour. Remember, per means we're going to multiply it times the number of hours, which is unknown, with an activity fee of $95. That would be a one-time fee that you're going to add on to the tuition. How many hours of classes can she take if she spends $1,175? So here is the total. So think about how you would set that up. $135 per hour plus a one-time activity fee of $95, and she's going to spend $1,175. So we have the 135 times x, that represents the number of hours, that's what x represents, plus our one-time fee of $95, and the total is $1,175. Now to solve again, we locate where the variable is. We're looking for x right here. We're going to move what's not attached to it first. So we're going to subtract 95 on both sides of the equation first. And that is going to give us 1,080 left on the right side of the equation. Now our variable is being multiplied by 135, and the opposite of multiplying is dividing. So we divide both sides by 135. And 1,080 divided by 135 would be 8 hours. So that tells us that she could take 8 hours of classes, and that's the money that she will spend. Again, we can check the solution. We think it's 8 hours, so we're going to plug 8 in right here to hours. So that would be 135 times 8 hours plus the $95 activity fee. We do our multiplication first, and that would be 1,080 plus 95, and it does check. So she can take 8 hours of classes. We're also going to be translating and solving two-step equations. So we're going to practice again translating. 8 less than, if you remember back towards the beginning of the year, when we have the phrase less than, whatever is before it, that's actually going to come at the end of the equation that we write. 8 less than. 8 less than what? 7 times a number. So here's our variable, 7 times a number. When you see the word is, that's our equal sign, negative 29. So all I did was translate this. 8 less than 7 times a number. So the 8 goes after the 7 times a number, and it equals negative 29. Now we're going to solve the equation. So to solve it, we are going to first move what's not attached to the variable first. So we're going to move the negative 8 to the other side first by adding 8. When you add 8, you have 7n left on the left side equals negative 21. Now we have to divide both sides by 7, and n would equal negative 3. Here's another example. 20 more than. When you have the phrase more than, we know that we add 20 more than twice. If you remember the word twice, that means we're multiplying something times 2. Twice a number, so there's our variable. 20 more than tells us to add. Twice a number is 2 times the number, is the equal sign 52. Locate our variable, which is right here. We're going to move what's not attached to the variable first. So we're going to move the 20 to the other side of the equation first. So we're going to subtract 20. That leaves 2n on the left side and 32 on the right side. Now we have to divide both sides by 2, and n would equal 16. If you're looking at workbook page 4.6, number 1, I'm going to do a few with you. We're going to translate these. 11 less than, again, there's that phrase 11, so we know this is going to come after what's this said next. 5 times a number is 5x. Is your equal sign 24. So 11 less than 5 times a number is 24. And when we solve that, first, here's the variable. So we're going to move what's not attached to the variable first. So we're going to add 11 to both sides. That leaves 5x on the left side and 35 on the right side. Now we divide both sides by 5, and we find that that number would be 7. The quotient, remember that quotient means we're going to divide. The quotient of, whatever they say first is going to go on top of our division. The quotient of a number, so it goes on top, and negative 9. So when they say the quotient, you know you're going to divide. Whatever they say first goes on the top. Whatever they say last goes on the bottom. The quotient of a number and 9 increased. Increased means to add by 10. So we write 10. Is our equal sign 11. So here's how we wrote that equation. The quotient of a number and negative 9 increased by 10 is 11. We're going to move what's not being attached to the variable first, so we're going to subtract 10 on both sides. Now, if the variable is being divided by -9, and the opposite of dividing is multiplying, so we're going to multiply both sides by -9. And when you do that, these cancel out, and you're left with -9 as the number. Okay, Ken is thinking of a number. 9 more than, so we write the number 9. More than means that we add. Product means we're multiplying. What are we multiplying? 4 and the number. So we're multiplying 4 and a number, so we write 4x is our equal sign, 73. So Ken is 9 more than, it's 9 plus the product, multiplying 4 times the number, equals 73. We move what is not attached to the variable first, so we're going to subtract 9 on both sides. Now, the variable is being multiplied by 4, so we divide 4 on both sides of the equation, and we find the number to be 16. So there's some examples off your assignment today. I hope that helps.